Hi, hi. My name is Dr. Barker, as you can see. I'm here just putting together this video for you to cover some of the content that has been taught in the Math Clinic. And the purpose of this video is just to ensure that every student who wants to have access to the resources can get them, but also see what the lesson is like for students in the classes. So these are free videos, and feel free to share them with anyone. Now today, because we feel strongly that math is something that everyone should enjoy and experience. So hopefully, as I work through the topic, you'll feel motivated to learn more and ask questions. And I wish you all the best. So today's video is going to be on trigonometry. We're going to focus on using trigonometric ratios in this lesson. And so we're just going to go through like sine, cosine, tangent, show some examples, share some strategies, share some ideas, show you the way that I think about these problems, provide a kind of conceptual view of it so that when you work through these problems, you don't have to learn many different formulas, but to see this as one continuous approach with different tools that you can use. And so this is also for people, quite likely most of you would have been familiar with the ratios already. So this is not so much like a first time lesson, but I still teach it from a beginner's perspective. So some of the stuff I would have gone into a little bit more detail, for example, to explain like how you apply trigonometry and the meanings of some of these ratios. But just for the purpose of just giving you a quick, sharp lesson on this, what I'm going to do is just share this with you. Feel free to check out, if you're interested in other lessons, you could send me a link and say, hey, I want this one. Or you can even, if you're a teacher and you want to see some of the stuff we're doing, you can always join the Facebook group as well. I'm on Twitter, I'm out there. So without further ado, I'm going to get cracking. As I said, we're going to be working on right-angled triangles. And we're going to be doing some work on right-angled triangles. And I have a funny name for right-angled triangles that many people don't see. I call them rats because of R-A-T. So as I'm working through this, you may see me mention this as being a rat. That's what I mean, R-A-T. And that's going to be useful when I start to work through the problems. You'll see the connection. So for today's lesson, we're going to be focusing on right-angled triangles and how we can use trig ratios to solve them, those trig questions. All right. So let me just get this away so we can see that clearly. And so let's get going. So the trig ratios are some relationships that exist between pairs of sides on a right-angled triangle, on a rat. Remember, it's a rat. So we call it a right-angled triangle. I call it an RAT, a rat. And one thing to bear in mind is that if you look at the word ratio, you will see RAT as well. Sometimes students forget that the ratios are actually relationships that exist on the right-angled triangle. So one way to remind yourself is that when you see the ratios, you see rat. And you can say, I only use the ratios on right-angled triangles. So remember that if you know where the right angle is, you know where the hypotenuse is. And if we have a reference angle, let's say A, so we're starting from A. The other sides, as I said, are now possible to be described. I'm going to shorten this and just write opposite, but I know that this means opposite to angle A. And likewise, I'll call this adjacent. I know that this is opposite to angle. This is adjacent to angle A. Very important that you keep this in mind. Now, in math, we say the cosine of angle A, and we write this as cos A, but we read it as cosine A. We don't have to say cos A, we just say cosine A. Sometimes people say cos A, it's not a problem, but I like to say cosine A, even though I write cos A. Likewise, the sine of the angle is written as sine A. Don't say sin. I really don't like your kids saying sin. It doesn't work for me. It's sine A. So we keep the meaning of the words. And likewise, the tangent of angle A is written as the tangent of angle A, or tan A. All right. And as long as you get familiar with the connections between the actual ratio and the shortened form, there's no need to worry about it. You'll be fine. Now, these ratios are relationships that exist between different sides on the triangle when an angle is identified. So cosine A is the relationship that exists between the adjacent and the hypotenuse, and it's a special relationship. It's where the adjacent side is divided by the hypotenuse side, and that's a special relationship called the cosine. Okay? Likewise, the sine angle, the sine ratio, is the opposite side divided by the hypotenuse. That's another relationship that could exist, that exists, and it's just called that name. And then tangent is the opposite side divided by the adjacent side. I refer to them as being divided, but remember that this can just be written as a fraction. And most times when you do these questions, these will be kept as fractions. Now, so as I said, if you know the right angle on the, if you have a rat, then there's a right angle. And if there's a right angle, then we know the hypotenuse. We always know that. We always need to know which angle we are working with in order to describe the positions of the sides. That's critical to understanding this. As I said, cosine A is adjacent over hypotenuse, and sine A is opposite over hypotenuse, and tan A is opposite over adjacent. Now, we are mathematicians and we like to write shortcuts. So sometimes we don't bother writing adjacent over hypotenuse. We just write A over H. But if you're in this, you'll know exactly where this is coming from. Likewise, for sine, we write this as O over H. And for tangent, we'll write opposite over adjacent. Now, because of this shortened form, it allows us to create a little shortcut representation of the different ratios. So you'll see people go SOH, or SOH, and that's sine, it means that sine is opposite over hypotenuse. Likewise, CAH means cosine is adjacent over hypotenuse. We know that all these relationships are fractional relationships. So it's a ratio. So we have opposite over adjacent. And students, you'll hear they go SOHCAHTOA as a way of remembering it. And it's going to be powerful. If you can remember just what these are written as, remember the ratios and where they're applied, you'll be okay. So that's very important for you guys. So remember, until we identify the side, we do not know what is opposite, what's adjacent. We only know the hypotenuse. So these are the three ratios: sine, cosine, tangent. Okay, let's have a look at some examples and see if we understand. I'm going to do some applications of this now. I'll do a number of examples, and hopefully by the time I work through these examples, you will be in a position to understand where I am with this, okay? Just hopefully by doing that. So let's get going and working on this, okay? So what I do when I see a problem like this, I start to think and I go into what I call the thinking zone. So on this side, this is what's going on in my brain as I make decisions about what to do next. On this side, I am working out the problem. So if you're working out the problem, this is really what is happening on the paper, and this is happening in my brain. Now, what I'd like to do is to teach you, share with you what's happening in my brain, and then you try to be like that, you know, because you want to be like me in mathematics. So I'm looking at the problem and I'm going to take some information about what's happening in this problem. So when I look at the problem, I see one side given and one angle given. See, so I have a side which is 8 centimeters and I have an angle. And I'm asked to find another side. Because I see angles on the RAT, the right angle triangle, I know that this is a trigonometric ratio problem because I have angles and sides. For those of you who are of knowledge of Pythagoras theorem and sometimes get confused, remember Pythagoras theorem is only applied to sides. You cannot use it to do angles. You use Pythagoras theorems to work on the sides only. So if you see any right angle triangle, any rat, you can say, I smell a rat. Because you see this, you know it's a rat, and then you know there's an angle involved, so I know this is the trigonometric ratio. So once I've identified that this is a trig ratio, I write down the three representations. So, ka, toa. Now, what would I do now in order to know what to do? Which of these three? The majority of students I know have challenges with this topic, don't know which one to choose. So I'm going to show you how at any situation, this is going on in my brain, how you choose which one to use and don't make a mistake. So the first step is to say what's given. I know that the hypotenuse is given because that's 8. So I cross off the h in both of the ones that has 8. So I just cross off the hypotenuse. Then I go back through and I said, what am I trying to find? And I realized that, or what other information that is relevant to this problem? And that's the adjacent side to the angle. So I cross that as well. Now notice that one of them is crossed twice. Okay, this one has been, it's like this one has been like double crossed, meaning someone, it is the one that has to be to answer to the question, because someone double crossed, they point you out and say you are the person. So being double crossed is the one that has been somewhat informed upon, and now this one has to take on the challenge of solving the problem. So because they get selected twice, they win. Okay, so I know that this is the cosine ratio. Now, my approach to math problems is if I know what ratio I'm going to work with, I state it. So I go cosine of P is adjacent over hypotenuse. I substitute the values which I know. So this is my thinking side. This is my action piece. This is what I'm putting into action. So I know P is 35. I know the adjacent is X, and I know the hypotenuse is 8. So now I'm going to continue to work this out. I'm going to simplify this or rearrange or solve, and I'll cross multiply. So that just gives me X equals 8 times cos 35. So in this case, I just multiply both sides by 8, and that gets me here. And then all I have to do is go into the calculator, figure out how my calculator does this calculation, and then you need to remember that your calculator needs to be in degrees in order to do this. So X is 6.55 centimeters rounded to 2 decimal places. Very important that you look at the degree of accuracy that your question, the question requests, and make sure you do that. In these questions, I tend to do length to 2 decimal places depending on how big the lengths are, and I go for 1 decimal place for angles when I'm finding angles. So this is the process. So remember my thinking zone. Let's look at another one. So again, we have another problem. This is triangle ABC. We have the hypotenuse that's given. We're asked to find the side that is opposite to the angle. So my first thing is go in the thinking zone, and I say I have one side and one angle given. Need to find another side. The fact that I've just said angle and I'm on a right angle triangle, I know that this is ratio. So I'm going to go for the trig ratios. Okay, I know it's trig ratio. So I write down SOHCAHTOA again, and then I'm going to do the same process. I'm going to check. So I know I've been given the hypotenuse, so that can be crossed off, and I'm being asked to find the opposite side. So I cross O off. Now, which of these have been double crossed? Sine. You see, sine has been revealed just by going through that process, by saying, I have the hypotenuse, I need to find the opposite side. I now know that it is sine. So I write that down. I say state the sine ratio. And we know that sine is opposite over hypotenuse. Very important to state which ratio you're going to use, because in most exam marking scheme, just identifying and stating the correct ratio would earn you 1 mark for method. So it's very important that you do that. In most exam marking scheme, they'll say site of sine. And you don't even have to maybe write the right ratio. You just need to know that this is about sine. So this process here is a guaranteed 1 marker already for you. Let's continue. So we're going to substitute the known values. Remember, this is my thinking side and this is the working side. So sine 52, putting the 52 in, replacing the pieces, x and 17. And again, this is a very straightforward question because the hypotenuse is given and it allows us to cross multiply. Very, very easy to solve this problem. So x is 17 times sine 52. And again, make sure you type this into your calculator and you get 13.40. And that 0, you could check when you work this out. I've rounded it to 2 decimal places. Again, keep thinking about what happens in my thinking zone, but this is all you need to do when you're working the problem out. This is really all that is sufficient to work the problem out. I state the ratio. You don't really have to state it here, but it's recommended as long as you get this right. But if you get this wrong, or if you jump here and you do it wrong, then you lose all marks. You will lose some marks. So try and just make sure that you state the ratio. So only 3 lines of work, really. So let's go. Triangle TUV. And again, let's have a look at this problem. Get in the thinking zone right away. What do I need to, what do I have? What do I need to do? I have one side and one angle given. I need to find another side. Angle means trig ratio. So this part I've talked already about, very straightforward. So ka tower, again, I'm going to check to see what information I've been given. I've been given the adjacent side, so I can cross those off quickly. And I'm being asked to find the opposite side, so I can cross those off. Now, which of them has been double crossed? Tangent. So I state the tangent ratio. From here, the tangent of T is opposite over adjacent. My next step is to substitute the known values. So I'm getting tan 64 is y over 11.3. Notice when I'm working, I don't need to carry the units because it's not important. It doesn't affect the work. It just adds to it. If there were different measurements, I'd convert them to the same units, and then I'd carry on with this. From here, I'm simplifying. And again, I just cross multiply here to get rid of the denominator, the fraction. And this is very straightforward, 23.17 centimeters. So I hope we're doing all right here. So we're carrying on. Another example, and this one I think I've just put this stuff down. So in my thinking zone, one side and one angle given, need to find another side. Again, it's trig, sine, cosine, tangent. I'm gonna cross stuff off. Simple. I'm trying to find, I know the adjacent. I need to find the hypotenuse, and I know right away that this is cosine. So let's take the cosine ratio, and we go on quickly to the cosine of P, adjacent over hypotenuse. Substitute the values. We know these steps already, very straightforward. If you're working through this and you just want to make sure that you're, just pause the video. Don't worry about my pace. Just pause the video, work through the problem, and then check to see if you're on the right track. Now, because we have the hypotenuse is what we're trying to find, you're going to realize that the simple solution here is just to swap these two. In reality, what we're doing in math is multiplying first by y and then dividing by cos 34. And so y is 11 over cos 34. This normally happens if you're trying to find the hypotenuse, or when it comes to tangent, if you're finding the adjacent, the adjacent side. But that's something you can get used to if you do enough examples. I'll do another one. Same, one side, one angle given. Need to find the other side. Again, it's trying to find the hypotenuse. We cross off the opposite side in this case. We cross off the hypotenuse because that's what we're trying to find. And we know this is sine ratio. So we state it. Substitute the known values. Yep. And then again, we have the denominator situation here. So we just swap them around. All right. So y is 9.34 over sine 37. And again, we can divide, work this out on your calculator, and you'll get 15.52 centimeters. So again, very important, the thinking zone is what I'm thinking. Here is the working out. This situation is the other situation that you'll have to look out for. But as long as you put stuff in the right place, you'll know when to swap them and when to do that, when to just do 2 steps. It's really a 2-step, but if you do it enough, you'll know it's just swap them around. It will be okay. Let's get another example, PQR. We're in the thinking zone. In this case, we have 2 sides given, but we need to find an angle. So we're still working with angles. So it's still trig. So ka tower. Now let's see what we have. We have the opposite side, and we have the hypotenuse. So we know already, without even knowing what to do next, we know that this is sine. So we state the sine ratio. Then we write down that. Substitute the values as before. As I said, pause the video if you want to have a go at it at this time. It's up to you. But I'm just working through this. You can pause the video anytime. So it's 9 over 12. And then we need to, now here's the situation. This is one that I haven't done yet. In this case, we're finding an angle. Now, we cannot divide by sine, which is what many people might think. The opposite, we do what we call the inverse operation. So on your calculator, you may have to find the inverse function of sine. When it is activated, you will get sine to the -1 to find the angle. So when you click on your calculator, and some calculator you see shift buttons, some calculator you'll see second function, and some you'll see inverse. It's up to you. But you keep working with it and ensure that it's in degrees, and you'll get the sine inverse function, and then you just operate that function on 9/12. And then you'll get your angle when you press equal, which in this case is 48.6. So very, very important that you understand. As I said, this is just a very short lesson on an entire part of the syllabus. Very important to bear in mind. Remember, you're working on a RAT, right angle triangle, and RAT is the first three, they are the first three letters in the word ratio. So if you're on a right angle triangle, the trigonometric ratios are the perfect ones to use. And so very, very important that you keep that in mind. The thinking zone that I talked about, that's my way of thinking through this. I want to make sure that I don't make mistakes. And so I go through that crossed-off method is very, very useful. And so make sure that you are applying that crossed-off method in order to do the work. And that will help you to master this topic. Remember, in an exam, if you state the ratio correctly, you're almost guaranteed to get the first mark. And if you practice using videos like these, then quite likely you won't make a mistake through that. As you do trigonometry, it's important that you get familiarized with your calculator, because that's going to be useful. Also, don't buy a new calculator before the exam, because some of the processes might not be the same on every calculator. Likewise, you need to make sure that your calculator is in degrees, because while there are many other ways in order to find, there are many other ways in which you can measure angles. So don't assume that it's only degrees. Trigonometry, very powerful topic, very useful topic. There's more to learn in trig. We're only working on right angled triangles. There's a lot of other triangles, scalenes, isosceles, but in reality, all of the other ratios are derived from the trigonometry. All the other formulas are derived from the trig ratios. And I have a video on Facebook, on YouTube, that you can watch proving the cosine rule. So hopefully this is useful to you. You can watch this video and then you can have a go at some practice questions. And if you have any questions about or any videos you want, just let me know. Please sign up for the Math Clinic. If you want to sign up for the Math Clinic, you send an email to jmedetf@gmail.com, or even to me, that will be fine. And let us know. This is reaching out to any student who needs some help with math. It happens every Sunday, 11:30 a.m. Eastern Time. And Mr. Fullerton and I, we deliver the classes and we help you with your math. So this is to help those who can't make it into the class. You can watch the video and then you'll be okay. So I just want to say this is our aim, to help you with your mathematics. And thanks for joining us on this video. Peace out, and signing out from that. So today's lesson was on using the trigonometric ratios, and I hope my explanation was helpful to you. So signing out, Dr. Barker, leaving you with another mathematics video to make sure that you enjoy your exams. Bye-bye.